to ask questions in the chat, or actually, there's a button to raise the hand. So, welcome
Yeah.
to the Kubernetes Book Club. Today is March 1st, and we're starting a new book, Kubernetes Platform Engineering on Kubernetes by Marisa Salatino, and we have the pleasure of having him, the author of the book, on the book club himself, talking and discussing their book. Go ahead, Mauricio.
There you go. Thank you very much, folks, for joining. And yeah, I wanted to, join the first chapter just to do a quick introduction about the book and what the book is about and the reasons behind writing the book, I guess. And we can go over kind of like the first chapter and just discuss about different topics that you might be interested. I do have like a discount code that you can use. I think that you can scan that QR code if you are interested in getting the book. But I also will be sharing kind of like other resources that I'm referring to in the book that you can use without buying the book too. So it really depends if you are interested in reading the book, which I totally recommend. But if if you don't, if you cannot buy it or something, just please get in touch and I will share kind of like these other resources. There are a bunch of things that I wanted to share about the book, and the book took me at least like a very long year and a half. I would say like almost 2 years in writing. And when I started writing the book, platform engineering wasn't a thing. So I wanted to give a little bit of background about why did I decided to write the book and some of the assumptions and perspective that this book is taking, so you can like know what you're getting when you start kind of like reading the book. I think that I'm very explicit on the perspective that I'm using for writing the book, but I think that it's always good to to be upfront about those kind of things. I don't know, Carlos. Like I will just do this quick kind of like intro about like some of the background stuff behind the book. But if you have any questions, feel free to interrupt me, and we can jump into the content like straight
Yeah.
away.
I think
Yeah.
it's super interesting, right? When we get a book,
Mhm.
there's so many hours invested when you write a book.
Mhm.
I know because a lot of friends like Chad, for example, right?
Mhm.
Talking to folks like Chad, like this takes time and takes time from your family, right? On weekends, a
Yeah.
Saturday that you can spend with your kids or something. So there must be a reason why you're writing a book, because nobody's making becoming rich of writing books, right? So you
That's
need to have
100% right.
something. So it would be good to both personally, like why you took the challenge of writing this
Mhm.
book, and then the
Mhm.
second one could be like why talk about platform engineering as a topic, right? Why you pick that
Yep.
topic?
Perfect. Yeah, I think that that makes a lot of sense. I think that the first thing that I wanted to mention about the book is like I do consider myself like a developer still. Like after all these years, I've been working with open source for like like 12 years in my career, and I had the luck to be working for companies that pays me to do that. But at the end of the day, I'm still a developer that wants to develop tools or applications for other other developers to be more productive and more more effective when they are doing their jobs. So I've been doing kind of like a lot of like tools and that kind of stuff. And when I started working with Kubernetes very early on, like I would say like early 2016, I realized that from a developer perspective, like Kubernetes will be pretty hard for teams to adopt, and it will take quite a lot of tools and a lot of a lot of learnings in order to get up to speed with that. So since then, I basically did a lot of work on building frameworks and building tools to help developers just to be able to use Kubernetes. The book itself, again, it's like it comes from that developer background that I have in my in my personal experience, and I try to make it as hands-on as possible with tutorials that are not hello worlds, right? Like I didn't want to do like let's do a hello world on Argo CD, let's do a hello world on Crossplane. I try to show the tools in context with a like an application that I created just to show how these different tools can be applied. But it has a context. It's not just like let's just use the tool and see how it works. It's like if you have this kind of situation, this is how the tool will work for you. And each chapter, most of the chapters except chapter 1, has like a tutorial into this repository that I think that you can follow all the tutorials without like looking into the book's content. The book will give you the reasons behind these tutorials basically, and the glue and all the context around these tools. So feel free to check that out. It's a repository here in GitHub. It has a bunch of stars. If you give it star, I will really appreciate it. And most of the time, I recommend people to fork this repository and just change the applications, change the tutorials for whatever thing that you're trying to do. Um,
Yeah, this
this,
is
yeah.
just a quick comment. This repo was very useful, at least for me. I think last year you had this book in map, so I was reading the book, um, and I went through the code, and I actually this repo helped me build a presentation that I did this in YouTube of platform engineer on AWS, and I think one of the chapters was talking about cross-plane, and I needed like a real app,
Mhm.
microservice app, so I used yours, and I was able to do the presentation, and I forked it and made the changes. So it's if you want to have good examples, this repo is very good.
Yep. And it's kind of like good. I'm super happy because it has become like a community thing, right? Like people contributing to the examples just to make it better. And for example, I had contributions to translate this into different languages, right? So I have like it's in English, of course, but also like it's full in Chinese. The 9 chapters you can read them in Chinese. And I have some people working on the Portuguese translation and some people working on the Spanish translation too, right? I think that again, these examples are things for getting you started, but they're always like, if you look into the tutorials, you will find that I'm always suggesting what's the next step. And if you are feeling like implementing the next step and contributing back, all those contributions are always more than welcome, just to keep building kind of like some kind of like knowledge base that it's very hands-on and applied to a context that you can just reproduce quickly in your own environments. You don't
Your
need
star count
to.
has gone up a couple already.
Nice. I can just refresh. There you go. 5 more. This is the beauty of live streams. Thank you very much for that. I really appreciate that. And yeah, that's kind of like the context there. Let me go back here. Again, focus on Kubernetes, of course, because of the title and the CNCF landscape. And during the process of writing the book, I realized that the CNCF landscape, it's great, but there are tons of other tools out there that you should evaluate too. So I added kind of like a bunch of other things that are not currently part of the CNCF, but I think that I wanted to, just to mention that CNCF is great, but there are a lot of other things going on. So you just need to keep an eye on things, and it's good for you to, just have a broader view as well. The focus is on software delivery. Again, it's in software delivery, but not focused only on CI/CD. Quite the opposite, right? Like again, it's coming more from all the things that you need as as a development team, just to get things out in front of your customers. And I don't claim anywhere in the book or like in this presentation or in this session that the book is perfect. So all feedback is very, very valuable. Like positive and negative feedback, just get in touch. Get like if you have any comments, please bring it back, because I'm pretty sure that I will just write a second edition at some point, and I would just want to add as much feedback as I can get from like real readers and people that it's working on the field. I think that I can cover like the list of the chapters, but I think that I usually use the topics, like the chapters list, just to mention that the reason why I wrote this book is because I was actually contributing to at least like 10 different open source projects and getting involved with these projects, because I tried to use them and then I found that something wasn't working as I expected, or tools didn't integrate it well together. So I just went into these projects, created issues, created pull requests, and after interacting with 10 different projects, I realized, maybe I do have like a background story to connect all these tools together, and that's basically platform engineering. I did write a blog post because the original title of the book, like 2 years ago, was Continuous Delivery for Kubernetes. And I realized that that's kind of like what we are chasing after, right? Like we want to deliver more software in front of our customers and be efficient while we're doing so. But how do you do that? The what is actually like you do it by, practicing platform engineering and bringing some kind of like of cultural aspects about how do you coordinate, how do you integrate all these tools together. I try to keep the book very, like small on definitions. I'm not trying to define what platform engineering is, but I want to show you how it looks like and how integrating these tools for like a very specific context will look like. And you can do like your personal evaluations, read a little bit more about like how platform engineering works on the cultural side of things, for you to just get a holistic view about how to implement platform engineering in your companies. Again, I try to keep it as practical as possible. Hopefully that makes sense, Carlos.
Yeah, it's going to be hard to write something that covers every permutation, but you can say that
Mhm.
that the book it implements a end to end reference implementation of a platform engineering stack, right? On how it would look like for a team. Other teams may
Mhm.
pick a different tool for a different area, right?
Mhm.
Change
Mhm.
Tecton for Argo CI/CD, or
Exactly.
change, a different tool for the different capability.
Mhm.
But the book, I think you said, like, I had experience with this specific projects. So if somebody's going to
Capabilities.
put them together,
Mhm.
how would someone put it together? There was no book out there, right? So that you saw the
Mhm.
opportunity, like, well, let me write a book to help someone to put them together so they can see an end to end, because it's usually blog post after blog post. It's a
Mhm.
blog post of a component, a tutorial
Yeah.
about a component, but never like the end to end story. I think the last time I saw that was like before Kubernetes, like Jenkins CI/CD and VMs,
Mhm.
right?
Exactly.
That's the last time I saw like a story about, and it was around Jenkins.
Mhm.
That you were able to do everything in Jenkins and Jira, maybe, right?
Good. Yeah. Jenkins, Jira, and VMs. Sounds like
Yeah,
fun.
and VMs.
Uh-huh. Perfect. Yeah, I think that I don't want to claim that I created some kind of like reference architecture here. More, I think that I tend to think that what I wanted to do with the book is to show people how to evaluate different tools. And for showing how do you evaluate different tools, I picked some tools from the landscape, some tools that are not even covered in the landscape, and just show it to people so when they look at them, they can evaluate if that's what they need to solve their particular problems, right? So for the chapters, I try to describe a generic problem that you might be facing, and then some tools that are going to give you some answers to that problem, and then how much work are you going to need to put on top of the tools to make them do whatever you want to do.
I agree. I agree.
Cool, cool, cool. So I guess that's kind of like what the first chapter is about. Is just setting up the context for the rest of the book, right? I try to explain at the beginning around a little bit about like platform engineering, that it's not something new in our industry, but it's something relatively new in the Kubernetes context, right? We started talking about platform engineering like I would say like maybe a year and a half ago. I don't know, Carlos, a year ago was definitely becoming more relevant, and now it's becoming full on.
Yeah, and I think I don't know what multiple places have been writing about this and giving presentations,
Hmm.
but the platform engineering comes from the need of standards. Like, I
Hmm.
was looking back on, like, just forget about Kubernetes, right? Just or IT, just platform engineering. And I was looking back, trying to do research, going back where the term came from, and I
Hmm.
found that it came from the manufacturing industry, like
Yeah.
CDs and diskettes, right? Like,
Hmm.
companies trying to build something, and like you needed different procurements. Like you were building, like, I think it was, I'm going to look it up, but I think it was Sony was trying to create the Discman, right?
Hmm.
And they needed to procure the parts from different vendors around the world, from China, from India, from different parts. So
Hmm.
these parts need to come in. So how did they create a standard that all these, like, they can choose a vendor, another vendor for a part for their Discman, that they follow a standard, right? And following a
Exactly.
standard on how to produce them, so the quality of those parts come together like with high quality.
Hmm.
So Sony needed to give those vendors of the components, like, guidelines, maybe a framework, maybe a platform, maybe a standard that they were able to build these things, and then they will put it together. I didn't talk
Exactly.
about IT, right, or software, right? It's
Yeah,
platform engineering. So it's
but I think
engineering a
yeah,
platform of our own standards.
yeah, and at the end of the day, it's like so you can compose your own things, right? Which
Yep.
I think that it's like a common theme, kind of like in platform engineering. How do you glue things together to do whatever you're trying to achieve, right?
So if you're in your software stack using Linux,
Hmm.
and for the last 3 years you have been using, I don't know, Debian or Ubuntu,
Yeah.
and then the next 3 years you're going to switch it for Red Hat, or the
Hmm.
next distribution of Linux. Is it easy to swap them or not? Like, what is Linux a standard? Like, how difficult will be? Another company give me support for Linux, right? Because maybe this
Hmm.
company that I was using just disappeared, and then now I have to, like, but I'm still using Linux as a standard. So the
Hmm.
next wave is like, now cloud native. I need cloud native standards. So how do we put together uh, these things together to offer a standard? And then I think the platform engineering on Kubernetes, I think they took it to a different level, or maybe extend the definition to say, in other areas that I work with, was share services. Like in the company, there's a team in charge of providing common services. Like if somebody needs a memcache server, then you went to that group to get a memcache, and then the team didn't have to create their own memcache server and configure it. Like if the team needed a database, right, they went to the team, to this team that it was in charge to give them a database and procure a database to a ticket, and then they got the database to build the application, right? And
Exactly.
so, but that was like, that takes too much time at scale. So how do you provide something? I don't want to define something with the same word. Like, how do you define something that the team can just go and self-serve,
Exactly.
right? And request what they need, and they get it in a way that is standard.
Yeah, and again, like a standard might be kind of like inside of your company, right? Like it doesn't need to be standard for every company, but it's like, what do your teams need? How do you offer them that in a way that they can self-serve and have like APIs or like a way to request those things, like based on what they know about the context and the problem that they are trying to solve. And I think the book focused a lot on that, right? Like this first introduction basically try to go into that, like the scenarios where you might need a platform, going on a very light definitions about like platform being collections of services that will help companies to get their software running in front of their customers, right? Like whatever companies and teams might need to deliver software can be part of a platform, and you can have a team building these collections of services just for your teams consuming these services to have a simpler life, a simple life cycle, like fast feedback loops on what do they need and how they can provision those things. There are like a big tendency in the industry to go and say, like we are doing more like ClickOps nowadays instead of going and request and create tickets for provisioning databases. Cloud providers have made our life much easier, where we can just click a button and get a database or a Kubernetes cluster. But the book focused on the next level, right? Like sometimes you don't want to go and create a Kubernetes cluster. You want to create an environment that have everything that you need in order to work with your applications. And I think that that's the kind of platform that the book is trying to talk about, right? Like not basic stuff like give me a database. It's more like give me a cluster, a database, my application running, so I can just focus on working on this very specific service that I need to change.
Exactly.
So I go into explaining a little bit about like the different layers of services that cloud providers offers, and this can apply also for on-prem kind of like situations. But how do they charge, right? Like the lower level of abstractions, like compute, it's going to be in a way cheaper, right? Like because it will be cheaper than buying your computers and running your networking layers and all that stuff. So you can get computers cheaper. But if you start adding, like more like software level, like operating system and some software running inside those operating systems and observability tools and a bunch of stuff, then you will need to start paying more, right? And then I go like this kind of like blue layer here is much more closer to applications, right? Like you need databases, message brokers, identity management. All these services will be actually more expensive, mostly because the cloud provider will take care of the entire stack. So you will need to pay more for that, but also because they are solving topics and things that will take you quite some time to implement inside your companies if you need to start from scratch, right? Like if you need to choose your own identity management solution, install and run that inside your company, you will need to go through all the layers and just do all that stuff. For smaller companies starting, this is great. You can get started pretty fast. For large companies, this might end up in very large bills. Sometimes you need to balance, if you go to a cloud provider or you do this yourself, depending on how mature your organization is. And I kind of like evaluate a little bit that, and then I just go into examples, right? Like if I need a database, I'm kind of like in this layer, and I will need to pay for not only running the instance of that database also for the maintenance and for the backups of that data that I'm using and for the storage that I'm using. So it's like a bunch of different configurations and considerations that you need to make when you are adopting a cloud service, which is well known at this point. But I needed to introduce all these layers in order to be able to talk about how these platforms apply for different organizations, right? Because no matter if you are consuming kind of like a PostgreSQL running in Google Cloud or in AWS, right? It's still the job of your organization to understand how to combine all the cloud provider services for your particular problems. So even if you're not using Kubernetes and you are adopting a cloud provider, you need to go to the cloud provider, look at all the services that they are providing, all the frameworks that they have, all the tools that they have, and then start making choices about how these services will be combined for your specific company. So I talk a little bit about that, like all the work that you will need to do. I guess that if you're adopting a cloud provider, you are doing platform engineering already. And if you are like on top of Kubernetes, you will be doing that with a specific set of tools, with a very specific set of communities, plus with cloud providers. Because if you're running Kubernetes, there is a lot of chances that you are running on a cloud provider, unless you are a very large company running stuff on premises too. So I talk about like the separation about that, like what's provided by cloud provider, services that are common from third-party services, and then yes, organization-specific services, right? Like these are the software that you build inside your company, maybe using all these other things, but just to solve specific problems for your organization, and that how that compares with just using tools that are already designed for solving these problems, but also how kind of like the work and the balance of using a cloud provider might help your organization, or it might be too expensive for your organization to consider. So go into that a bit, and then I think that this is kind of like where the meat of the chapter is, which is about like what are cloud providers offering you and what can you get from the Kubernetes community. I don't know, Carlos, if you read this part and like got the idea behind the tooling that we are used to consume nowadays.
Yeah, so I saw this chapter, and yeah, the cloud provider has. I think you mentioned at the beginning like requesting tickets and going from
Yes.
tickets to APIs, and that's kind of
Mm-hmm.
like the nut to crack of
Yeah.
that you're going from you can say like opening a Jira ticket is an interface, but it's not
Mm-hmm.
programmatically interface. Like you open a Jira ticket into your org to get an environment, right?
Mm-hmm.
And then that takes time because maybe it's done manually. So
Mm-hmm.
the because it gets manually, or that team is actually turning around and using SDKs and CLIs and everything to the cloud provider to create
Mm-hmm.
and provision the environment in the right way. That is mostly a lot of people delegate that to one team because that team is specialized on a cloud provider, and they know how to optimize both for performance, reliability, and for
Cost.
cost. That's
Yeah.
the most important one.
Mm-hmm.
So that's why the team will ask you things like, do you need a large database or a small one, right? And
Mm-hmm.
that's the ticket that you open. Do
Yep.
you need it? Do you need it forever, or can we shut it down on the weekends, right?
Mm-hmm.
And that was and that took time because you opened the ticket, didn't put that information, you send back an email saying you're missing this information, and by the time you get everything done, it's end of the year. So how do we
Exactly.
make it? How do we make an API, right? An API
Mm-hmm.
driven that like the dev team can use an API to request what they need, and then this team is in charge of the abstraction, how that API is allowed, not allowed to do. So it's a level of abstraction. So the cloud service provider gives
Mm-hmm.
you the APIs to that team to do whatever they need, but that team has the responsibility of sharing what they need to share in a way that becomes a standard inside the company. So yeah, accessing the service APIs, and the cloud providers provide you like script, example, SDKs. At least in my company that I work with, we work with the community, and the community actually builds this stuff like Terraform, Pulumi,
Mm-hmm.
Crossplane, CDK, Perl, Golang, Python SDKs, everything
Exactly.
out there, right? So you can build your own abstraction for
Mm-hmm.
when the dev asks for an environment. He's not asking for a database; he's asking for an environment, like you said, right?
Exactly. But I think that that's really important. At the same time, it's like, yeah, it's recognizing that cloud providers, which are like very large service providers, basically they do that API driven approach, right? They will give you the APIs first, and then when the APIs are stable, they will probably make those available via dashboards, right? Like that you can go in a UI and access that functionality. And when all that stuff is working, you will have the SDKs, so you can start automating things, the SDKs and CLIs. So teams can start automating the work against these services, right? Because sometimes the UI is not the best way of accessing it. Sometimes you don't want to like create scripts to send like REST requests to a service API. You just want to automate using applications or using like CI tools just to automate the work that you need to do against those APIs. And I kind of like use this kind of like diagram to compare what we do, with a cloud provider for creating Kubernetes clusters, and how do they offer kind of like all these things like a dashboard for automating things, the REST APIs and the CLI tools that basically will allow you to do the same thing, but using kind of like different things for different teams that are interested in doing, different things. Like a developer will prefer an SDK, maybe someone writing a CI task for like a integration testing environment, they need to send a REST request basically, or the CLI, right? And comparing that, like, how does that work for Kubernetes, right? I really wanted to do this comparison because when we interact with cloud providers, we have tons and tons of services, right? Like I'm pretty sure that AWS is the same, but the Google Cloud CLI, it has access to, I don't know, like 200 services or more, which is insane. And when we look into the Kubernetes space, we have done a great job of having the Kubernetes APIs, which are basically used for all the projects that I'm covering in the book, and the kubectl CLI that allows us to interact with those APIs. We have, SDKs for most of the languages there, and we have some Kubernetes dashboards that are pretty good to understand what's going on inside of our clusters. But don't forget that Kubernetes is all about like running workloads, right? Like these APIs are only about like running and scheduling workloads in our clusters, which is a lot already, but we need way much more tools and features in order to get our software up and running there, right? So we need to install things into our clusters, like monitoring tools. We need to, maybe run some pipelines in there, or maybe run some pipelines outside for building containers and distributing containers. So with the Kubernetes APIs, we are solving some problems, but I think that that's why we have this book, basically, because with the Kubernetes APIs alone, we can just not do all the things that we want to do. And there is kind of like a journey there that I cover after this, about like, okay, which tools I'm going to use to solve all the other challenges that are around running workloads in production.
At one point, Mauricio, is
Yeah.
at least I like to tell stories based on my experience when I started
Mhm.
working on these things. And uh, right, you can correlate to people like I when I started learning Kubernetes back in 2000, I don't know, 16 or 15, I was using it. All the documentation that was available and I was learning was kubectl, and I call it kubectl. Some people call it kubectl.
Yeah.
Never in my mind went through that there was a HTTP API. Never,
Mm-hmm. Mm-hmm.
ever, never, ever. If I had known that there was a HTTP API back then, I was doing a lot of Perl. I could have
Mm-hmm.
like switched from writing Bash scripts and Perl, writing the kubectl, and I could have just like write. Was Perl? I think Perl was before that. I think at that time I was doing a lot of Node.js. Like
Mm-hmm.
I was a developer advocate. I created things like Cordova and PhoneGap, and I was a web person, a web head. I could have used Node.js to
Yeah.
do all this job, and I was writing Bash scripts in Jenkins, because it never crossed my mind that there was an HTTP API. Like
Yeah.
people don't know what they don't know, right? Um,
Exactly.
and it was an HTTP. I could write a web app with Node.js
Mm-hmm.
and then provide a little website that says you want a namespace and you want what do you want to deploy, and then deploy, versus
Mm-hmm.
me writing Bash script and Bash script for kubectl.
Exactly.
So these are things that you learn in this type of books, right? And things that you learn from other people. So
Mm-hmm.
that's kind of key. That is an API driven platform. There's an
Mm-hmm.
API for Kubernetes. There are actually APIs for cloud providers. A lot of people start their cloud provider journey of like tutorials, certifications, and the only thing that they see is the GUI, the web app.
Yeah, exactly.
And then they say they see the cloud provider CLI, and never their mind cross that they're using HTTP.
Mm-hmm.
Maybe I'm aging myself, because back in the days, the only way that I talked to servers was using SOAP and envelopes,
There you
right?
go.
So
Yeah.
so having HTTP, right, being
Mm-hmm.
a very flexible API and standards that you can use from any SDK,
Mm-hmm.
um, allows you as a programmer, right, to write programs to interact with those services. And at the same time, you become a platform engineer, because you're writing a program to offer a service to your teammates, right, or in your organization, providing that abstraction. But it's very
Yeah.
important to highlight that the API is kind of like the HTTP API is kind of like the thing that drives everything from this point on, right? That
Mhm.
ability to work with things, and something that it didn't cross my mind back in 2016. Like I didn't
Yeah.
know if Kubernetes has an API.
And I think that that's very important. Like it's a very important part of the story, mostly because if you don't automate with these tools, then you will spend a lot of time, as you mentioned before, right? Like if you don't have APIs to glue different projects and do like different tasks in sequence or like just coordinated or parameterized things that you want to do, there is no way that you can be successful because there are too many things to do in order to enable teams to do their job, basically. So automation is key, and using these SDKs, I think that it's pretty important. Understanding the hook points that Kubernetes provides, it's also very important. And understanding that there are already like hundreds of tools already created instead of you creating your own tools to solve problems. I think that it's also like another important piece of the puzzle. And I think that's pretty much what I cover next. It's like the adoption journey and the ecosystem, right? Like how does it work, right? Like usually, at least in my experience, I've seen companies saying we will go in full into Kubernetes. What they don't realize is that adopting Kubernetes is not enough, but they will just need to understand how the CNCF landscape works and the tools that are already there. And they also need to understand that they will need to go into understanding these tools and understanding how these tools can be, combined together to solve more higher level use cases, right? And something that it's becoming more and more clear in these last 2 years is that you can actually encapsulate all the tools that you choose behind APIs. So you expose APIs for your teams to use, and those APIs are contracts that you will use to say, this tool is working fine, so I can keep using it, or this tool is not working that well, but I already have strong APIs on top of this tool, so I can start switching some of these tools for other things that be might be more and more helpful for my use cases. I think that process of realizing that you need more tools and that then you need to combine these tools for your particular use cases and using that concept of APIs on top of those decisions will help you to be successful on your on your platform and in Kubernetes adoption journey.
On that
Mhm.
one, at least in practical, I think you're going to cover next.
Yeah,
The next is choosing from here, right? Choosing the
exactly.
ecosystem.
Mhm.
Um, some to clarify to folks is like all these like logos that almost doesn't fit in here. They
Yeah.
are not CNCF projects,
Mhm.
right? This is why it's a lot of confusion in the field. These are not CNCF projects. It's called the CNCF
Landscape.
landscape, but it's not not
Yeah.
CNCF projects. They're almost like I think we have now with Particle 13. You can
Mhm.
filter, say which are the CNCF projects, and I think there are like 13 graduated projects. I
Mhm.
think 10 in incubation. So that's one way of also for platform teams to evaluate um, if they're going to pick a project, like if it's graduated or not graduated, it's a sandbox or not sandbox.
You can
And
see
then the
here.
rest are just open source and vendor tools
Mhm.
available in different
Exactly.
different spaces. But the platform team, will pick some of these projects to build their own platform, right? To offer the APIs, and that way they create an abstraction to say maybe we switch one for another tool, or we use the open source, we use the vendor open source tool,
Mhm.
right? But they don't have to change the API to their developers or the audience. So that's why a lot of time invested in platform engineering is defining what will be the ideal interface or APIs to the team, right? The consumers.
Mhm.
And in practice, a lot of platform engineering teams, they spend more time picking the tool than actually designing a good API. So I would say you spend time less on picking the tool and spend more
Mhm.
time what is the ideal interface for your organization or your developers, because that thing will not change. Like that should not change
Exactly.
that often.
Exactly. I think that that's the key of all these things, right? Like how you can abstract the complexity of making the right decisions from this. from this landscape that it's pretty big and it's pretty complex, right? I don't want to complain about the landscape, but it's like that's key here, right? Like you need to understand these tools, you need to understand what they were designed for, and then how you're going to combine them to do whatever you need to do. And this is where I like do my shameless plug. And I'm working. I didn't introduce myself at the beginning, but I'm working for this project it's called Dapper. It's part of the CNCF, and we applied for graduation now. So if you're interested in this kind of stuff, you can actually help a project to get graduated by providing feedback in their pull requests for graduation, and that will basically tell us how important do you think that the project is. And again, this is a community process. So
and in the last case, just if you highlight again, you will see that it says incubation next to it, right?
Yeah, here.
There's just
right?
a little bit of a feedback.
Yeah.
Teaching the community how to navigate this landscape. A lot of people complain
Exactly.
about the landscape, but I think maybe it's just a miscommunication on how to navigate it. So here you see like Dapper is a CNCF project that is incubating and have gone through different requirements to get to incubating, and now they're in the final steps to become graduated. So it's a project that is not driven by one company; it's driven by multiple companies that have a best interest that this project is successful.
Yeah, and that the project will not go away if any of the companies working in the project, they stop funding it. So that's the whole point here, and that's why I'm sharing kind of like the issue, because the issue shows that the project basically looked into the state of the project, and you said, okay, we are accomplishing all the things that are required by the CNCF, and then the CNCF will look into how people react to these pull request issues and define which project is graduating next. So it's kind of like unbelievable, like kind of funny to see how much people is like pushing for this project forward, and of course that we are super happy to see that happening. But going back to the book, I think that we have another 10 minutes. Is that right, Carlos?
Yeah. Let's end the book and then we can take questions. Let's see if we can do that in 10 minutes.
Yeah. Let me go back like for the last, like the second half of the chapter. So this is the first chapter. Like again, choosing from that landscape, understanding the landscape is really important. And again, just realizing that the landscape alone, like Kubernetes alone, will not take you that far. With the landscape, you will be able to solve a bunch of other things. But of course, most of the time you will be running on a cloud provider, so you will need to learn cloud provider services and how do they work and what services do they offer. And at the end of the day, what we are trying to do with platform engineering is to reduce the complexity of all these decisions for the teams consuming these tools to develop applications, basically. That's the main challenge here. Like, we explain all the complexity, so we know that there is complexity there that we will need to abstract using APIs. I go over that. I go a little bit about the cultural aspect of it. There is this book called Team Topologies that it's been mentioned a lot in platform engineering presentations. This is mostly about the cultural side of things, right? Like, this is the changes that you need to implement in your organization to be able to have like platform engineering teams building platforms. I find the topic very fascinating, but I'm not focusing on covering a lot of details around this because I'm more focused on the hands-on experience and the tools that I wanted to cover for the book, that I think that are much more like hands-on. It's like not how do you change your company to apply these tools. It's more about what these tools will do for you and how do you combine them together. So I go over that. I go about like that abstracting complexity and enabling teams to push more features in front of customers, which I think that that's the main goal. And then I covered, like, I have this small section here where I basically try to argue that it's very difficult just to buy a solution off the shelf for your company, because no matter which projects are you using, if you're just choosing Kubernetes as the main target platform for running your applications, tools like OpenShift and tools like Tanzu are great because they combine a lot of open source tools together to provide some experiences. But you need to know that you will need to learn how those tools are combined there, and probably you need to add more tools of your own in order to actually implement stuff. These tools are great and they will take you very, very far, but there is always that learning about what's happening in the community and just looking into which tools are being used to solve different problems. So just going into getting one of these tools will not take all that complexity away, and sometimes it will add some complexity of learning these tools and how these tools were designed. Again, I'm not against any tools, but you need to just need to know that the complexity is going to be still there. And go the same, kind of like the adoption with tools. But again, it's all about like integration at the end of the day. I do believe that this book says that like loads of time. This is all about system integrations and how do you integrate tools to achieve whatever you are trying to achieve. And I think that the second part is giving context of the examples that I'm using in this repository that I mentioned. So this repository basically is implementing a small application that it's composed by 4 different services and using a bunch of infrastructure like databases, message brokers, and things that application will use. I use the concept of walking skeleton, which is like a minimal, like it's like a POC, like a proof of concept or a demo application that it's kind of like implementing the architecture of the distributed application in this case. I took this concept because I really like the idea of implementing an end-to-end flow of the application, like a feature that the customer can consume. And I'm using this example of a conference, like a conference application that allows you to submit proposals for presentations and then accept proposals from different, potential speakers. And if you accept the proposal, it will be showed in the website. If you discard it, it will send an email saying that, that proposal wasn't accepted. And I wanted to implement the entire cycle just to show something working and then something that you can go and change and break.
So Mauricio, I
Mhm.
did, maybe it's cultural where I grew up or anything, but I didn't know what a walking skeleton was. So
Yes.
I read it from your book and I went online searching like what is walking skeleton, and actually there was documentation out there that
Mhm.
that it's the thing like of walking skeleton, and I can give you feedback on like I have been using walking skeleton with some engagements that I have done in platform engineering
Yeah.
that I did last year, and this is perfect. That this matches. I don't know if it's based on your experience or not, but this
Mhm.
matches what I've seen in practice in the field, where when we work with a organization and they come to us saying we want to do platform engineering on your cloud and we want to use
Mhm.
Kubernetes. It's a big take to start implementing their own platform and platform engineering, and we use this strategy of like asking them pick one app, like
Mhm.
just pick one, and they try to pick three and like no pick one.
One.
pick one app, and then say like what is the pain point of this app. It's like
Mhm.
a lot of time to provision it. It's difficult to provision a different
Mhm.
cluster, and those type of things. I think my thing froze for some reason.
I can hear you
Um,
still. Yeah.
but yeah, so it's called a walking skeleton. So the walking
Mhm.
skeleton, we asked them is like pick one app,
Mhm.
and we're going to take that one app, one app, like this even smallest thing, and we're going to go through the process of doing platform engineering from beginning to
Mhm.
end for this app
Mhm.
to find the unknowns, like find all the
Exactly.
unknowns of building a platform, and
Mhm.
also you will learn you will learn so much of doing that first one app of like you're
Mhm.
going to learn like how to install Crossplane for the first time, how to
Mhm.
install Argo CD for the first time, how to do security and observability for Argo and Crossplane, how you're going
Exactly.
to move from Terraform to Crossplane, or how you're going to work with Pulumi, or how you're going to work with multi-cluster and vCluster, how you're going
There
to
you go.
work with abstractions like Knative, how you're going to do CI/CD. That one app may take 3 months, may take 6 months, but at the end you can
Mhm.
then do the other 99 apps faster.
Exactly.
So that's why it's good to take one app and go through the whole process and find all the unknowns to build
Mhm.
the first. The first one is the one that will teach you how to do the other ones, but it's called skeleton, I guess, walking skeleton.
Walking skeleton, the idea is that to have like the minimum bare bones that implements like a functionality end to end, right? And for this, for the book, basically, I took the conference idea to say, like the conference application will need these 3 or 4 services to interact between each other in order to implement that functionality, right? So I have 4 services that are going to run as containers in my Kubernetes clusters. And all these services are needed just to implement that flow, right? Like of sending proposals, accepting them, and notifying people if they got accepted or not into the conference. And I wanted to use this as the context for talking about platform engineering, right? So this is the application. In chapter 2, you will run the application and you will see all the things that can go wrong with the application itself. But from then on, it will be all about like the tools that you need to get that application running into different environments, and how to get this application in front of customers, basically, and then how to measure that the tools that you're using are the right tools.
But this
That's pretty much the book.
the app, but this app, I don't know if you mentioned it here or not. Maybe you did.
Yeah.
But these services, these 3 services that you see here, they have their own dependencies on databases, queues, all these. I don't know. We call it like stateful services, and then you have the choice of you can run them inside Kubernetes next to it, or you can run them on a cloud provider, right?
Exactly.
But the developer should care, maybe not, right? That's kind of the thing of the next chapter.
Exactly. Yeah, and that's kind of like the whole point, right? Like you have tons of different combinations on how you can do things on Kubernetes. This book is basically asking those questions, exactly like what you're doing here, Carlos, is that if I have 3 options, which one should I take? And I will just try to present the different options and the pros and cons for these options, right? Like you can run the database that this service needs in your cluster, but then you will need to manage it. You can run in a cloud provider, but it will be expensive. What are you trying to achieve with your application? What are exactly your needs? And based on that, how do you implement applications that can be moved across environments without changing the entire thing, right? How do you build applications, and how do you run applications in a way that they are not so tied to maybe a cloud provider or like an environment that it's very specific and has like a very specific version of the database? I'm trying to cover all these things kind of like in following chapters. Not everything in chapter 2, but those
and these are
topics
containers, right? These are microservices.
Yes.
These are cloud native containers. So perhaps the team want to build a platform that the developer doesn't even know that the container is running on a VM or running on Kubernetes or running in a cloud provider service that is a container service, like in production, right? It could be in production, is not running Kubernetes, but Kubernetes is being used as the API to implement the API for the platform.
Exactly. And that's why I thought that it was really important in chapter 1 to show the context and to show that it's not the hello world, right? Like it's like 4 services, a front end, and a bunch of infrastructure that it's needed just to run the application. And also to show that even if you can run this application locally, right, like by creating a kind cluster, there will be a limit to how many applications, how many of these services you can run locally, and how much is that going to complicate the developer experience.
I'm working on something like that. I'm working on a Canoe project, and it's based on Kind, but I'm running a platform, an IDP on Kind, and it's like you said, my laptop doesn't handle it, but I'm running on a VM, right? I have a server here, so I'm running on a server, a VM. I'm running Kind there just to do development of the platform, and then eventually I'll run it in the real thing. But yeah, Kind, I love Kind. I cannot say better things like Kind.
It's really good. Kind is really good, and I know that you master it, like you know every detail of it. So I'm using Kind for the examples here. So most of like all the examples here in this repository, you can run it on a Kind cluster, right? Like the tutorials will go over like the creation of the cluster, configuration of the ingress controller, and then just deploying apps.
In Knative, we spend a lot of time in user experience to make Knative work smoothly in Kind. So, but yeah,
it's pretty good. And then so I strongly recommend you to check this out if you're interested in this topic. I think that I give you kind of like an overview about what the book is about and the approach that I'm taking and some of the tools that I'm covering. But I would say that tools will come next in the next chapters, right? Like you can see here the list of chapters. Let me show you here. So I have here, right? Like just a quick overview of chapters.
Sevi will help you on that one. Sevi, I think Sevi was going to cover that one.
Perfect. Next week.
Before we end, just want to open it to Sevi and others, Satish, chat questions, feedback to Mauricio on the book, or comments about looking forward.
Going into clients, I always had this big burning question about how you measure success and how you measure your team's success, right? I'm so glad that this book is touching on that as well. I can't wait for that chapter.
It's a really hard thing to do, right? But I think that we as an industry, we need to work more on those tools. that's why I really push hard on that chapter. That was, of course, the last chapter that I wrote, but also like the chapter that took me the most to get the examples out, because I thought that if you cannot measure your platform initiatives, it's like you're just working in the dark,
Yeah.
right? Like you're just adding tools and you don't know if they are making your life better or miserable.
How come I'm funding this platform engineering team and I'm not seeing any results? Like,
Yeah, what's
I'm giving
happening?
like I'm funding, and this team is not showing me like what things are getting better and by how, right?
Yeah, 100%. Like
So
what?
the
Yeah, exactly.
IT team needs to also think about like how do they show up, like the value that they provide to the organization, right? Doing IT because it's fun and it's automated, that's not enough.
Exactly.
So thank you, folks. I think we had a good attendance today. I don't know if somebody wants to have some comments from Mauricio or questions. Interesting topic, not interesting. Just trying to get some feedback. Have a thumbs up. Good.
Thank you, folks. There you go. Look at that.
Shows that, yes.
And somebody has the hard book. I don't have a hard copy.
You can get one in at KubeCon.
Yeah, give me one. I'll signed. That'll be good.
Perfect. That's awesome. Yeah, 100%. Yeah, guys, if you are coming to Paris, please get in touch. I will be around most of days. I have like 3 presentations too, so just come and say hello. And I know that Red Hat will be sponsoring some copies too. So, stay alert because like there will be some book copies there.
Okay. So if you attended and if you're in Twitter reading all those tweets from people or LinkedIn about they're trying to define platform engineering, tell them that they can come to the book club and help us define it, right? So there's a lot of hot takes out there. So they can join every week and have their hot takes here of what is platform engineering, what is DevOps, and what is DevOps dead, and platform engineering is the new thing, right? We can argue all day about that, but I think this book is practical to like the practices, right? It doesn't get into hot takes or opinions.
Yeah, and that's the thing, right? Like I didn't want it to go there because I believe that there are tons of projects doing great things. There are tons of companies doing great things, but it really depends on what you are trying to solve. You will need to make a choice for your context. There is no escape from that, right?
Yep.
There is no silver bullet, right?
Yep. Okay. Well, and with that, thank you, Mauricio, so much. This is a privilege to have like the book author join us and talk about the book they wrote. No one else has more passion about the book than the book author. So this is amazing, right? You can, it doesn't get better than this.
And I think that's the same thing, right? Like even if I'm really passionate about this, the book is not perfect, the repository is not perfect. Feel free to create issues or write me in Twitter or complain about it everywhere so I can make it better for the second edition.
Yeah. We'll give you feedback. I'm here. Thank you so much, folks. Have a nice weekend.
Yes, Mauricio.
Thank you, folks. Bye-bye.
Have a nice weekend, everyone.